degrees. Okay? So in this diagram, we have two parallel lines cut by a transversal. Remember, a transversal is just a line that slashes the other two. And it says, suppose the measure of angle 8 is 132. Find the measure of angle 2 and 3. This is just like yesterday. Okay? So all of us go to angle 8 and write in 132. So we remember angle 8 is 132 degrees. Okay? Ava, why would 2 be the same as angle 8? What is the name of those? She's right. Nope. Alternate exterior. Nicely done, Tyler. Alternate exterior. You're absolutely right. Maybe you want to make a little note of that to yourself. 8 and 2 are alternate exterior. 8 and 2 are alternate exterior. That's why you end up where you know that angle 2 is 132. Okay? Now I have to figure out angle 3. How am I going to figure out angle 3? Manny?
By subtracting 132 by 180.
Very good. Because what type of angles are these? Very good. 180 minus your 132 gives you 48. Yep. 48 degrees there. Just a note to yourself, 2 and 3 are supplementary. Very much yesterday. Agreed? Okay, perfect. So we easy in like that. Here's where we step the difficulty up. Next problem. In the figure below, O, this means parallel. O is parallel to M. Find the value of Z and X. So if you notice, Z and X are inside that diagram. Okay? What we have to do is we have to use our angle relationships to be able to set up, are they alternate exterior? Are they corresponding? Are they vertical? To be able to set up equations. Notice, they give us a 76. Miss Hoff's strategy is, let's get that 76 to as many places on this diagram with our angle relationships as possible. Okay? Where else can I put 76 based on supplementary, vertical, alternate interior, alternate exterior, corresponding? Mason? Here? Absolutely. It is 76 down. Whoa, maybe I should get the right pen here. 76 down here because it's vertical. Nicely done. Ava?
Under the equation.
Under the equation right here?
Yeah.
How can... Very good. You have your Z. You could do alternate interior as a Z. With Masons, you could do corresponding as well, correct? Kind of make an F. Any place else 76 can go, Mason? Very good. You could go corresponding or even vertical from Ava's, right? So we can get that 76 throughout that entire diagram. Okay. Well, technically, we haven't answered any questions they asked us. Now, I need to be able to look at the X and the Z angles. Can I find an angle relationship with one of the 76s that I could set up an equation? Let's use the Z one first. What angle relationship can I set up with any other 76 that I have? The one right next to it? This one right here? What relationship do they have? Very good. They're supplementary. Okay. So angle Z plus 76 equals how many degrees? 180. Pause. Then subtract 76. And then you're right, Peyton. Z is 104. Yep. Okay. Now I need to do something with this 4x minus 40. Say what you're going to say.
How come it's not just like, aren't there just like two and then you like put it? Like so because of the alternate.
Absolutely, you can, Zoe. You absolutely can.
So it's 4x minus 40 and you put equals 104 because that's the coefficient of that angle and then you solve it like you would algebra.
Okay, perfect. And this is, I think, what Ava was saying too. Yesterday, she noticed that everything was like either one of two angle degrees, right? In this case, we have 76 and 104. And so Zoe tells us that 4x minus 40 is 104. How can she prove to me that it's 104? What angle relationship allows me to put that 104? That vertical right here, yes? So that means these two are equal. So 4x minus 40 equals 104. Now we solve this just like we did in chapter 2, any algebra equation. First thing I'm going to do, add 40 to both sides. 4x equals 144. Then I divide by 4, x equals 36. Yes, I was thinking 70 something. Nope, 36. What'd you say?
I still got it right, even doing wrong.
What'd you do?
I did 4x minus 40 plus 76.
Okay, do you know that you didn't do that wrong? Remember yesterday when I talked about there's so many different routes to get there?
Yeah.
Okay, my guess is that you noticed these are a line, right?
Yeah.
Okay, so he said I took 4x minus 40 plus 76 equals 180 because they're supplementary angles, right?
So we just added.
So then 4x, so negative 40 and 76 would be 36, right? Equals 180. Subtract 36. 4x equals 144. Divide by 4, and look what he gets. X equals 36. So you didn't do it wrong. You just saw it differently. Okay? And so that's the thing about this is there's different options. Some of you are going to stick with supplementary the entire time. Some of you are going to love corresponding. Some of you love vertical. What you see can still get you the right answer even if it's different than somebody else. Okay, flip it over. I think I have two more. In the figure below, angle 2 is 133 degrees. Find 1, 3, and 4. So angle 2, I'm going to replace with 133 degrees. Mason? And which one's vertical to that? Very good. Angle 4 is vertical, so angle 2 and angle 4 are vertical, which automatically tells us that we can put that 133 in there. Nicely done. How am I going to find 1 or 3? Jacob? Very good. 180 minus 133 is, say it again? 47, right? 47. So then we could just say like 2 and 1 are supplementary, right? So that makes this 47 and 347. Why? They're also vertical. Very good. Okay, they're also vertical. All right, now keep those brains, that same thought going as we move to the one down below, because now they just amp up what they have written in there. Find the values of z and x. Somebody was not giving me an answer. Can you give me some hints as to how I'm going to find z or x? Maybe?
114
Is going to give me what? Very good, because these two right here are supplementary, right? So 180 minus 114, which is 66. Yeah. So z equals 66. Okay. Somebody else. How am I going to find my other 13x plus 10 here?
Isn't it 114? Like you've got to add, like,
Right. Why is it 114? What type of angles are those? Vertical angles. So vertical angles are equal. 13x plus 10 equals 114. Then yes, you have to solve. To solve this, I should subtract 10. 13x equals 104, right? Eight. See what I mean by just amplifying what we've been doing? Yes?
Yep.
Questions at all? Hey, here's a random thing. Remember a long time ago, Miss Hoff used to say, when you multiply exponents, you keep the base. And what do you do to the exponents? Add the exponents. And when you divide, you keep the base, and
What's this?
subtract the exponents. Subtract the exponents. Okay? Yes, you will need work paper today. Your online homework is due at 8 a.m. You have the hour to work.
I love all